Hey everyone, and welcome back. In this video, we'll be building a secure 3-tier architecture on AWS using 3 EC2 instances. The 3-tier architecture is the most popular implementation of a multi-tier architecture. It's a well-established software design pattern that separates an application into 3 distinct layers: the presentation tier, the application tier, and the data tier. This separation enhances the application's scalability, maintainability, and flexibility. Presentation tier. This is what users see and interact with, like your website or mobile app. It displays information and takes user input. A web server delivering HTML, CSS, and JavaScript to the user's browser is a perfect example of this. Application tier. This layer handles the application's core functions and business logic. All the complex logic and user requests are processed by this layer. A Node.js server processing requests and managing data flow between the presentation and data tiers is a perfect example of this tier. Data tier. This securely stores all your application's critical information, like user data or product details. It handles the storage, retrieval, and management of data. A MySQL database storing user data, application data, and other essential information fits this role perfectly. A 3-tier architecture keeps your application organized, secure, and ready to grow. In this video, we'll be building one on AWS using React.js, Node.js, and MySQL. By the end of this video, you'll have a fully functional 3-tier architecture on AWS, ready to host your React.js application. So, whether you're a beginner or a seasoned developer, this video is packed with valuable information to get you started with building secure and scalable applications on AWS. So, let's get started. In this video, we're building a secure and well-organized 3-tier application architecture on AWS. Let's break down the key components. We're using a single virtual private cloud, VPC, to provide a logically isolated network for our resources. This enhances security by keeping our application separate from the public internet. Within the VPC, we have 3 subnets, 1 public subnet and 2 private subnets. Public subnet. This subnet has 1 EC2 instance functioning as our presentation tier. Here, we've deployed our React.js application served by Nginx, the popular web server. First, private subnet. This subnet houses another EC2 instance, our application tier. This instance runs our Node.js application managed by PM2 for efficient backend operations. Second, private subnet. This subnet houses another EC2 instance, our data tier. This instance holds our MySQL database, ensuring secure storage for our application's data. To ensure secure communication for our frontend, we've implemented HTTPS using Let's Encrypt with Certbot on the presentation tier. This encrypts data transfer between users and our application. To make our application accessible on the internet, we're utilizing Amazon Route 53 for DNS resolution. This service translates user-friendly domain names into the IP addresses of our resources. So, let's start building our 3-tier architecture in the next part of the video. Alright, let's set up the foundation for our application. If you'd like to see a detailed walkthrough of VPC creation, check out the linked video in the info card above. First, we'll give our VPC a descriptive name. Since this is a basic setup for demonstration purposes, we'll only be using one availability zone. Next, we'll need to create our subnets. We'll configure 1 public subnet for our web server and 2 private subnets for our application and database tiers. We'll also include a NAT gateway to allow outbound traffic from our private subnets to the internet. In this particular setup, we won't be using VPC endpoints for accessing S3 storage. With these configurations, let's create our VPC. Now, take a look at this resource map. This visual representation shows all the resources we've created within our VPC. Finally, we'll enable auto-assign public IP for our public subnet so our web server can be reachable from the internet. Alright, with our VPC foundation set, it's time to deploy the building blocks of our application, the EC2 instances. We'll be launching 3 instances in total, each catering to a specific tier in our 3-tier architecture. If you'd like a more in-depth explanation, I've pinned a separate video in the info cards above that dives deeper into this process. Feel free to check it out for a comprehensive walkthrough. Let's start with the presentation tier, the public face of our application. For this video, we'll leverage the free tier-eligible settings offered by AWS. Remember, you can customize these settings based on your specific needs. Before launching, we'll create a secure key pair that will be used throughout this video to access our EC2 instances via SSH. Make sure to save this key pair securely. Since this instance will serve users on the internet, we'll deploy it in our public subnet. We'll also configure a security group to allow essential traffic. This includes SSH access for us to manage the instance, as well as HTTP and HTTPS traffic for users to interact with your application. With all the configurations in place, let's launch our presentation tier EC2 instance. Once this is up and running, we'll move on to launching the remaining tiers. Alright, let's deploy the next piece of our 3 tiers, the application tier EC2 instance. This instance will reside within one of our private subnets, ensuring secure isolation from the public internet. We'll create a separate security group specifically for this application tier instance. This group will only allow SSH access for management and a custom TCP port 3200 from the security group of our presentation tier. This port is crucial because it's where our Node.js application listens for incoming traffic. By restricting access to this specific port, we enhance the security of our application tier. With all the configurations in place, let's launch our application tier EC2 instance within the private subnet. Let's deploy our data tier EC2 instance. This instance, residing in our remaining private subnet, will securely store our application's data. The launch process is similar to the previous instances, but with unique security requirements. We'll create a separate security group for this data tier instance. This security group will allow SSH access from the security group of the presentation tier. Additionally, this security group will permit traffic on port 3306, the standard MySQL port, from the security group of our application tier. With these security measures in place, let's launch our data tier EC2 instance within the remaining private subnet. Alright, let's set up the data tier. This instance, securely isolated in our private subnet, will store our valuable application data using MySQL. For a secure connection, we'll use our web tier instance as a bastion host with agent forwarding to access the data tier instance. Now, to get our data storage up and running, we'll install MySQL on this data tier instance. For a detailed walkthrough of the installation process, I've linked a separate video in the info cards above. Feel free to check it out if you'd like to see a step-by-step guide. Once MySQL is installed, restart the service to ensure any changes take effect and that the MySQL service is running smoothly. Also, enable the MySQL service to start automatically on instance reboot to ensure MySQL is always available. Next, we'll perform a secure MySQL installation process. This involves a series of configurations to tighten security, such as changing the root password, removing unnecessary users, disabling remote root login, and removing the test database. Now, let's configure our MySQL database specifically for our application. First, we'll create a dedicated database to store our application's data. Then, establish a user with appropriate permissions to access and manage the application database. We'll configure these permissions for the application user to interact with the application database effectively. Finally, we'll create tables and restore data. Alright, with our data tier securely set up, let's move on to the application tier. This instance, residing in our private subnet as well, will be the engine that powers our application. Just like with the data tier, we'll leverage the same secure connection method, agent forwarding through our web tier instance as a bastion host. Now, to prepare our application tier, we'll install a couple of key tools, Git and Node.js. Git will allow us to version control our code and collaborate effectively. Node.js is the runtime environment that will execute our JavaScript code on the server side. With these essential tools in place, let's get our application code onto this instance. We'll use Git to clone our repository, downloading a copy of our codebase from the version control system. Then, we'll navigate to the Backend directory within the codebase that contains our Node.js application. To enable our application to communicate with the data tier, we'll update the database credentials within our Node.js application. Host, we'll use the private IP address of the data tier instance to establish the connection. User, we'll use the username we created specifically for our application during data tier configuration. Password, we'll securely enter the password associated with that user. To ensure our application functions smoothly, we'll use npm to install backend dependencies. Finally, to manage our Node.js application effectively, we'll install PM2 globally. PM2 is a powerful process manager that will serve our Node.js application. It will keep our application running in the background and handle restarts if needed. We've securely configured both our data tier and application tier. Now, let's bring our application to life by setting up the presentation tier. Similar to the application tier, we'll install the necessary tools on this presentation tier instance. First, we'll install Git and download a copy of our application's front-end codebase from version control. Next, we'll install Node.js. Once we're in the frontend directory, we'll configure the environment variables our frontend application relies on. With the environment variable set, we'll use npm to install the frontend dependencies. Now, to securely serve our frontend application, including HTTPS for a safe connection, we'll leverage a powerful tool called Nginx. Nginx is a web server that excels at efficiently serving static content, making it perfect for our frontend application. Let's test our Nginx installation. We can access the public IP address of this EC2 instance to see the default Nginx welcome page. This confirms Nginx is up and running. Now that the environment is ready, we can build our React.js application, creating optimized files for deployment. These optimized files, also known as build files, will be copied to the directory Nginx uses to serve content. This essentially makes our frontend application accessible through the web server. To fine-tune Nginx, we'll update its configuration file. This involves specifying server name. We'll use our domain and subdomain. Setting root location, we'll tell Nginx where to find the build files for our frontend application. We'll configure Nginx as a reverse proxy, forwarding all API requests, usually starting with /API, to the application tier on port 3200. This allows communication between the frontend and backend. With the Nginx configuration updated, let's restart the service to apply the changes. Now, if you visit the public IP address of this instance in your web browser, you should see your application up and running. By default, public EC2 instances have dynamic IP addresses that can change on reboot. To avoid this, we can assign an elastic IP address. This static IP address can then be used for further configuration, like setting up Route 53 for a custom domain name. Once elastic IP address assigned to our public EC2 instance, we should be able to access our application under the new IP address. Now that our application is up and running, we'll use Amazon Route 53, a powerful DNS management service, to connect our domain name with our application. The first step is to create a hosted zone in Route 53. Think of this as a virtual container that will hold all the DNS records for our domain name, like a map to our application's location. Once the hosted zone is created, we'll need to update the name servers in our domain registrar's control panel. These name servers essentially tell the internet where to find the DNS records for our domain, now residing in Route 53. This update can take some time to propagate across the internet, so be patient. With the name servers pointed to Route 53, it's time to create the actual records for our domain. We'll create an A record that maps our domain name to the elastic IP address we obtained earlier for the public EC2 instance. This allows users to access our application directly through the domain name. We'll create a CNAME record for a subdomain. This subdomain points to the root domain, providing an alternative way for users to access the application. After a short wait for DNS propagation, you should now be able to access your application by simply typing your domain name or subdomain into a web browser. Route 53 will seamlessly direct users to your application. We've come a long way, and now it's time to add an extra layer of security to our application, HTTPS. This ensures a secure connection between your users' browsers and your application, protecting data transmission. To achieve this, we'll leverage a service called Let's Encrypt, which provides free SSL certificates. These certificates are essential for establishing secure HTTPS connections. To interact with Let's Encrypt, we'll use a tool called Certbot. We'll install Certbot on our web tier EC2 instance. Certbot automates the process of obtaining and managing SSL certificates, making it a user-friendly choice. Once Certbot is installed, we can request and install the SSL certificate directly into our Nginx configuration. During this process, you'll be prompted for your email address, which allows Let's Encrypt to send you important updates and reminders about certificate renewal. Since we've already set up your root domain and subdomain in Route 53, Certbot might automatically list both domain names for certificate issuance. It's crucial to ensure you select both the root domain and subdomain for SSL certificate installation. This guarantees secure connections for all variations of your application's address. After successful certificate issuance and installation, we'll need to restart the Nginx service for the changes to take effect. Congratulations! You've successfully secured your application with HTTPS. Now, when users visit your domain or subdomain in their browser, they'll see the secure HTTPS padlock, indicating a safe and encrypted connection. Alright everyone, that's all I have for today. I hope you found this video helpful in the context of cloud computing. See you next time with another exciting topic. Leave a comment below with any questions you have. Don't forget to subscribe for more exciting tutorials. I've also included a link in the description below to a detailed article about this topic.